Grateful for John Moore. My name is Mahir. Today I'm going to talk about my project, collision avoidance and path planning for mobile robot in dynamic environments. I'm taking this project under Maryland. Today I divided my talks presentation to five parts. I'm going to talk about the presentation, move to the objective, and follow by methodology. I'm going to show some results and simulation to generate by the conversion. Okay. So the introduction. What is the autonomous robot? Autonomous robot is a perceived environment where the mobile robot can understand the environment, and the plan is moved around the static or dynamic environment. Artificial life form. It is about self-intelligence, where can act like a human being using mind. And there is several kinds of sensors. Use ultrasonic, sensor, scanning sensor, laser sensor, laser also sensor. Okay, the motivation that make me doing this project. There is a lot of possible applications, such autonomous bus, firefighting. Uses sometimes in military to find a dangerous bomb instead of going human being to find this bomb. We can send robots who can detect this bomb. And groundwork for other adaptive application, human speech recognition. There is some companies in Japan they doing where the robot is able to differentiate between the voice between human and other human. Okay, the objective of the project is to develop the robust algorithm for collision detection and avoidance in dynamic environment, and to simulate the mobile robot algorithm in the MATLAB, and to use the artificial intelligence. And at the same time, we have to get the shortest path for the mobile robot to get to the destination. The methodology. Now we go to the methodology. Methodology first, we study the robot behavior, where the speed, how is the speed, power, and the turning angle, and the amplify factor. And after that, we go to the wall following and wall following mode, where we use the faulty logic in eyes. Obstacle avoidance mode. This is also we use the faulty logic. Okay, this is the faulty logic, where you can see here. This is here the controller, where there is three types of the faulty logic. And here we have 9 sensors. 9 sensors here act like an input. And the output we have the speed, turning amount, and amplifying factor. So the sensor, all the 9 sensors here, basically the mobile robot, once I design mobile robot, it has like 9 sensors, and every sensor is in 20 degree, and the sensor able to detect for 120 units. So this sensor will act like an input. So let's say there is an obstacle. The sensor will give some values, and these values is based on the obstacle. If it is very close, can send 1. If it is medium, can send 2. So in the controller, for the logic controller, can understand and can analyze these values, and based on it can decide the speed, the turning amount, and amplifying factor. Let's move here to the design of the mobile robot. This is the design of the mobile robot, where the sensor is attached. It should be in front of the sensor. So you are driving a car, and you should have an eye, so that your eyes, the most the sensor should be at the eyes. So here I designed the mobile robot, the 9 sensor, it should be in front. So once the mobile robot goes, so can detect anything in front of it. So no need to merge some sensor at the back. So we are not working to. As you can see here, there is 9 sensor from sensor 1 to sensor 9. Every sensor in 20 degree, and every sensor can detect for 120 units. Okay, let's move here to the most important part. This is we call it the flow chart. Okay, now the mobile robot is go here. Mobile robot is go here. Now our mobile robot have to go to destination. Now we have the environment is full of static and dynamic obstacles. Okay. The mobile robot, if it is reach the goal, it will go and stop. Not reach the goal is if not reach the goal, then if the goal possible, then at this time activate the goal reaching, and and in this diagram, we have three functions: goal, activate, reaching, and activate obstacle avoidance behavior, and activate wall following behavior. And all of these things, only one of them can work at the same time. Okay, if goal visible is visible, then go and find it and stop. If not, then the robot trapped in accurate shell is on. If there is no trap, then if it is yes, then the wall following behavior activate, and we have to, and there is the wall following function. If the trap is not trapped in U shape or any kind of shape, then after that activate wall avoidance behavior, where will be, as we mentioned before, after the avoidance, we'll go and find the goal physically. Once we find the goal, after that comes stop at the destination. Okay. So there is here there is some results. There is the results and discussion, results and simulation. I'm going to show you the third one, I think fourth one. This is the simulation here. Well, you can see this is the this is the mobile robot, and that one is the destination. And now the mobile robot is running, and this is the cube. This is the U shape, and now as you can see, the wall following behavior is activated, and the wall following behavior is activated at the nearest wall. So the mobile robot will not trap inside this area. So still activated until it goes out from the shape U shape. Then after that, the wall following behavior will be disactivated. After that, we'll go and find the goal. This is the wall following behavior. So now, as you can see, it stopped. Now it is going to the goal. Now it's trying to find the shortest path, but once it's find out that cannot go from that side since there is generated obstacles here. And now it's trying to avoid the obstacles and to go to destination. This is the algorithm I name it, and this is the last environment. This is the environment I name it mode, like complex shopping mall. As you can see here, there's a mobile robot, and that destination, this environment full of static and dynamic obstacles, and the mobile robot now should be able to arrive to the destination in short path and avoiding the dynamic and obstacles. And it goes from this side. Finally, we'll reach the destination. Actually, this project is not that easy. It's been a lot of time to make the coding and maybe stuff. So as a conclusion, the artificial intelligence techniques such as fuzzy logic and ANFIs were applied in design for mobile robot algorithm to avoid the dynamic and static, and it is successfully. In the simulation, the robot reached its goal without colliding with the dynamic and static, and the adaptive neural fuzzy logic interface system with basic controller is developed to assist robot